Hi, in this video we will study Beer-Lambart law and its proof. Well, the theorem says for a monochromatic radiation, absorbance is directly proportional to the concentration of the material and the path length of the radiation through the medium. So I can write absorbance is proportional to concentration, and also absorbance is proportional to the path length. Therefore, from these two relations I can write absorbance is proportional to concentration times the path length, and A is proportional to Cl. So from this I can write A is equals to epsilon Cl, where epsilon is molar extinction coefficient or molar absorptivity. Okay, now let's consider the proof of Beer-Lambart law. For this, I consider a material or sample with a thickness capital L, and let's consider that intensity of the incident radiation is capital I naught and intensity of transmitted radiation is capital I. And now I can say when the radiation passes through the material, the gradient of intensity di over dl is proportional to intensity itself. So this is my first relation, and now also I can say that the gradient of intensity is proportional to concentration of the sample. Okay, if there are more concentration, we know more intensity, more radiation is absorbed by the material. So this is my equation 2. Now from 1 and 2 I can write di over dl is proportional to ic. So we can write di over dl is equals to minus k times ic. So here k is the proportionality constant, and minus sign because we know when radiation passes through the material the intensity falls down. So actually this is a decreasing function, therefore it is minus. Okay, now we will rearrange this equation and integrate with suitable boundary values. So I can write this di over I is equals to minus k c times dl. So now I'm going to integrate this. Now if I integrate this, I have to integrate from boundary I naught to I. So I naught to I, and here the length 0 to capital L, 0 to L. So let's integrate this. So if I integrate this, then I'll get ln I with boundary values I and I naught is equals minus kc times, if we integrate this we get L from boundary values L to 0 to L. So we'll substitute then simplify, we will get here ln I minus ln I naught, which we can write as ln I over I naught. Okay, and I take this minus sign to this side, therefore it's minus ln I naught over I naught, and then we get here kc times integrate substituting L and minus 0, so we will simply get L. And I can change this log e base to log 10 base, so I will get minus 2.303 log or lg I over I naught is equal kcl. Here we have used the relation, for example ln x is equals 2.303 lgx. So lg means log 10, so we can use log simply. So I write down this log I over I naught is equals to, so here minus, I take this value to the other side, that means k divided by 2.303 times cl. Okay, so this is actually the absorbance by definition. So absorbance is equals to, I take this is a constant divided by a number, it's another constant, so I'll take that constant epsilon cl. So here epsilon is k over 2.303. so this is the equation that we obtain from Beer-Lambart law. So we just proved the Beer-Lambart law. Thank you.